Okay, so if an acid is a proton donor, and I have to consider a proton to be an H plus ion, all right? A neutral hydrogen would have one proton, one electron. If I take away that electron from hydrogen, I'm left with H with a positive 1 charge, which is essentially just a single proton. So when we say it's a proton donor, that means it gives away this hydrogen ion, right? It's able to give it away. So that means acids always have hydrogen in them, right? They have to have hydrogen because they have to be able to donate it to something else. A base, on the other hand, is a proton acceptor. Okay, so that means it takes that H from the acid and uses it in its own compound. Okay, typically once it does that, it makes water. Okay, so acids typically have hydrogens in them that they're able to give away, and bases typically have hydroxides. Okay, that's kind of what they're formulated like. And so if this H comes over and bonds with an OH, that leaves us with H2O, which is water, as a product of that reaction. So when we see an acid and a base come together, they neutralize or become water, which is neutral, right? So now they're no longer acidic or basic. Okay, so that's a really kind of watered down version, but yeah.
So it's probably wrong, but if you put vinegar with sodium.
Typically, when we see acids, we see hydrogens come first in the compound. So H2CO3, HCl, H2SO4, H3PO4. These are all examples of acids. And what do you notice about them? They all have hydrogen. And where does hydrogen come in the compound? At the beginning, the middle, the end? Does it matter? What's it look like? Hydrogens comes at the beginning. So for an acid, the way I identify if something is an acid or if it's not is hydrogen at the beginning, right? And if it's first, that means I'm going to use the rules for naming acids. Okay, that's how I identify what type it is. I can figure out if something is ionic by figuring out, does it have a metal, right? If it's covalent, it's two nonmetals. If it's an acid, it has hydrogen at the front. Okay, so that's how I identify it first. And then I have to follow the rules to give it the correct name. Okay, so here's where that little cheat sheet comes in that I gave you. Okay, you see this little cheat sheet? You will get to use this on quizzes or tests about naming. Okay, FYI, we're going to have a quiz on Thursday over our naming. Ionic and covalent and acid. So we need to pay attention today because this is going to be on our quiz. Okay? So we're going to use this little cheat sheet, okay? Let's take a look at what this says, okay? Top part just gives you an example. But this is what you need here, okay? It tells me that if my original anion ends with an 8, if it's carbonate or phosphate or sulfate or any of those things, then in order to be that acid, it's paired with hydrogen and it becomes sulfuric acid or carbonic acid or phosphoric acid, right? It changes its ending to end with an ic, okay? So that means if our anion, I'm just writing up here your cheat sheet stuff. If our anion ends in 8, then our acid becomes ic acid, okay? And that's exactly what your cheat sheet tells you. If our anion ends in ite, it becomes an us acid. And if our anion ends in ide, it becomes a hydro something ic acid. Okay, so let's break down how we get to any of these three categories, because this probably seems a little cryptic to you at this point, okay? Let's start with this one right here, H2CO3. Okay, I want to break down this compound and figure out what is its name. Okay, I have to look at what is left over. What is left over if I ignore these hydrogens, right? Because I want to figure out what anion is paired with hydrogen to build this acid, right? We always know that an acid is going to be some negative thing paired with at least one hydrogen to make an acid. So it's going to be an anion plus hydrogen that makes an acid. And so if I take away the H's, I'm left with CO3 with a -2 charge. Okay, how do I know it has a -2 charge? That's right. It had to have 2 hydrogens to make it neutral. So if I take away those 2 hydrogens, that leaves me with a -2. Or I could reverse my crisscross. Okay, so CO3 -2. I want you to find that on your, yeah.
So acids use the polyatomic ions.
They use the polyatomic ions and the regular anions. Yep, anything with a negative charge can be paired with a hydrogen and become an acid. Yep, good question. Okay, so find out what is this compound right here, CO3 -2. It's got to come from the box because it's multiple atoms. So what is it? Carbonate. Okay, so I paired carbonate with a hydrogen to make an acid. So if I come over here and look at my cheat sheet, that means I'm looking at an 8 anion. And so the name of this acid, H2CO3, just becomes carbonic acid. Okay, I take the regular root of our word and I change the ending or the suffix to be ic. Carbonic acid. So instead of carbonate, becomes carbonic acid. So here is the name of our acid. Okay, so we ignore the hydrogens and we see what anion did we build it from, and then we go with our naming rules from there. Yes or no? Let's say that I wanted the formula for phosphoric acid. So phosphoric acid. It means it needs to come from what? Okay, and it needs to come from, remember we have to take the root of it, so it needs to come from phosphate. So I need to go find phosphate in my box. Okay, phosphate is PO4 with a -3. Now to get it to be an acid, what do I have to pair it with? Hydrogen, which is a +1. And so how can I combine those to make it neutral? Because acids do need to be neutral. They're like ionic compounds in that way. So what would it become? H3PO4. Right? Phosphate's identity is to be PO4, so we're not going to mess with that. But we know if this is a -3 and I've got a +1, I'm going to have 3 of those hydrogens to make it neutral. How do we feel about that? Okay, do we know how to use our little cheat sheet, a little chart? Okay. Let's move on to another type. Okay, the next, a different one. Okay, so let's look at this one, H3PO3. Is this acid, are these the same? They're the same acid? They are not, right? They're not. And so I have to figure out what anion is PO3. Okay.
Phosphite.
Good, it is phosphite. PO3 -3 is phosphite. Good, because we know we take away one oxygen to go from 8 to 8. So this is phosphite. And so based on my cheat sheet, right, ite would become an us acid. And so this compound right here, this acid would be called phosphorus acid. Right? I take away the hydrogens and I was left with phosphite. And so I end my root with an OUS. And then I have to put acid on the end.
So is hydrogen ever going to be in the final name?
No, it will never be in the final name. That's a great question. Nope, we'll never call it hydrogen something acid. The only thing we get close to is if you look at your cheat sheet, if it's an ide, we call it hydro something acid, but hydrogen itself will never be in the name. Okay? All right, what about this one? H2S. H2S. Okay, if I look at what anion it comes from, it would be just a S with a what charge? -2, right? Because I had to have 2 hydrogens to make it neutral, right? It's neutral right here. So if I ignore those hydrogens, I'm left with S -2, what's the name of that one? Sulfide. That one I can find on the periodic table because it's not multiple. This is sulfide. So that means my acid name must be hydro. Good. Okay, this one's a little tricky. It's actually called hydrosulfuric acid. But if you would have just put hydrosulfic acid, I would have probably given it to you. I don't have really a rule for when the suffix gets tacked on. Typically, it's after an R. That's really all I can tell you. I wish I could give you a better rule than that. Kind of whenever you think it sounds good, okay? But if you would have put hydro, right, as long as the prefix was right, hydrosulfic, I would have given it to you. Okay, that's just a spelling thing at that point. Okay, but technically it's hydrosulfuric acid. Okay, because it came from sulfide, we had to add the prefix and the suffix there. Hydrosulfuric acid. Okay, I know that's a lot, right? That's a little bit tricky. You got to take away some things. You got to figure out what we're looking at. But do we feel okay about how to use the cheat sheet? Okay, let's do some more practice here. Let's say I want the formula for sulfurous acid. Okay, I want the formula. So I want the neutral finished formula with no charges for sulfurous acid. Okay. This means it needs to come from sulfite, right? If this is an OUS ending, it needs to come from an ite. And so I have to find that in my box, right? I have to go find sulfite in my box, which is SO3 -2. Would we agree with that? Did we find that in our box?
Yes.
Okay. And so I've got to pair hydrogen with it. And so my final formula should be H2SO3, right? SO3 is sulfite's identity. By having a -2, that tells me I need to have 2 of those hydrogens to balance that out, okay? Or you can do crisscross if you want, right? The crisscross works here as well. But hydrogen's always a 1, so it's easier to almost just say, how many do I need to make that balance to make it neutral? Okay, so H2SO3 is our final finished formula. Do you see any charges in that formula? No, we don't leave it like this. Okay, we give a final finished formula, no charges. Okay? All right, I'm going to give you 3. I'm going to have you try 3 of these on your own here, okay? If I give you the formula, you give me the name and vice versa. Okay, so I want that one. I want this one. Okay, you're gonna do those 3 for me. Jack, are you doing okay? Okay, that's okay. What do we think? Are we ready or we still need another minute? Okay, good talk. Okay, we're gonna go ahead. Nathan, what do you have on the first one? Did you come up with anything for the first one or no?
Yeah, I don't know if it's right.
Okay.
But
Hydro.
fluoric acid.
Like this? Or no hydro?
No, I had hydro.
Yeah, this is good. That's perfect. Okay? It comes from fluoride, so it has to be hydrofluoric. So it needs the prefix and the suffix there. Okay? Hydrofluoric acid. Very good. Okay, what about on the second one? Leia, did you have the second one for bromic acid? Yeah? HBRO3. Because bromate is a -1 charge. Good. Yeah, perfect. Okay, HBRO3. This was a -1, this was a +1, so they just fit together perfectly. Okay, very good. What about the last one? Kira, do you have anything for the last one? Okay, what'd you get? Chlorous acid. I would agree. Chlorous acid. Okay, because it comes from not chlorate, but chlorite. I'm seeing some erasing. Did some of us treat it like it was chlorate? Okay. All right, yep, comes from chlorite. Chlorous acid. Very good. Okay. Let's try some here. I'm going to give you all the formulas first. So you're going to give me the written name for these ones, okay? So let's try this. Okay, there's your three. So you've got to figure out, are they ionic, covalent, or an acid? And then we're going to use the correct naming system to name them. Okay, if you've got questions, raise your hand. Okay, we're going to try these three on your own. I give you the name, you give me the formula. Phosphorus dichloride. P, then what? PCl2. I would agree. Very nice. PCl2. All right, hydroiodic acid. What is it? It's just HI. Okay? HI. That's it. When we see hydroic, listen. When we see hydroic, that means we're dealing with just hydrogen plus one other element. That's called a binary acid. And so when we see that hydroic, it's hydrogen plus the ion by itself. No oxygen involved. Okay? So it's just HI. Okay? What about our last one, chromium phosphate? Somebody want to volunteer? Yeah, Nathan, what do you think?
Cr2PO4 minus 2.
Not quite. We don't want to charge in our final answer, so that's part of it. Anyone else have an option? Yeah, Evan, what do you think? Okay, give me the full name, full formula. CR. CrPO3 like this. Okay. Agree or disagree? That's not quite what I had either. We have any other options?
Wait, PO3.
Kira, what do you think? Yeah, that's what I had. CR3 parentheses PO3 parentheses 2. So let's figure out why that is.
How are you getting 3?
Well, I'm going to show you. Okay, chromium is a plus 2. So chromium starts with a plus 2. Phosphite is PO3 minus 3.
Oh. See, that's what I thought.
What'd you say?
But it could be a plus 3.
No, it can't be a plus 3. Phosphite is just take away one oxygen from phosphate.
No, I mean like chromium.
Oh, it can't be a plus 3 because I told you which one to use, right? The Roman numeral. Okay. So, listen. If I have it here, now I'm going to crisscross. I bring the 2 down and I bring the 3 down. So CR3, PO3, parentheses 2. When do I use parentheses?
So that you know.
When I need more than one of a polyatomic ion. Okay, so try these one on your own. First two, you're going to give me the name. Last one, you're going to give me the formula. Okay, not quite because I don't want a prefix on that one. That's okay. Is it ionic or covalent or an acid? It's ionic. So we're not going to use prefixes. That's okay. Tin what? Tin sulfide. But what do I have to include? The Roman numeral. And what is the Roman numeral for this one? Tin 4 sulfide. Okay, I know it's tin plus 4. Listen. If sulfide is minus 2 and there are 2 of them, that means that's a minus 4. And so to get that to be canceling, you have to have a plus 4. Okay, on the next one, what do we think? Maria, what'd you have for the next one? It's, really phosphoric acid, but I would have given it to you. Okay, so hydroic acid, right? Hydrophosphoric acid. I would have given you your point if you would have said phosphic Hydrophosphic, that's
You wouldn't have
fine.
given us the-
I would have. Yep, I would have given it to you. Okay, hydrophosphoric acid. Because if I take this away, I'm left with P minus 3, which is phosphide. Phosphide. That would be different, so I wouldn't give you the point there. Right? Because there's a separate acid that would be named phosphoric acid. If we just had phosphoric acid, it would be H3PO4, right? It would be different. Okay, what about the last one? Iron 3 selenide. Is it ionic, covalent, or an acid? Ionic, right? This one was an acid. So what's our formula here? Fe2 Se3.
Oh, I forgot the E.
Fe2 Se3.
I didn't know there was an E.